不是我的用户，就是这个片，大家都可以变出来。我把它把这个超长拍一照在里这个前提条件是，任何人都可以随便写一个出来，那是随便的看。
Hi everybody, welcome. This is welcome to the Law School of Hong Kong University. So who has been at the law school for the very first time? I bet you it's nearly everybody, right? Law school. Good, well welcome all, one and all. So my name's Brian Tang. I'm the founding executive director of LIGHT lab at Hong Kong U, which is a new program for interdisciplinary and experiential learning here. LIGHT stands for Law, Innovation, Technology, and Entrepreneurship. And so when I was reached out by Edmund, whom I know well, I co-chair the RegTech Committee of the FinTech Association. Edmund saying, Brian, we wanted to host our Hyperledger Meetup after our planned boot camp. Would you be willing and able to host it? And I said, very pleased to, because it's completely aligned with what we want to do, especially when I heard about who the speaker might well be, and talking about digital identity. So we're very pleased to host the, together with the Hyperledger Hong Kong Meetup, all of you here at Hong Kong U Law School. I wanted to open up the floor now to Selena von Vold. Yes? Salona. My apologies, Salona. I was focused on the surname and I still do it. So Salona, as was described to me, she's the boss. She made in a decentralized world, right? So she made all of this happen in terms of the wonderful boot camp that I believe a lot of you were part of, right? And now is a continuation on. So Salona, her official title is Global VP of Community Architecture of Hyperledger. She's fresh off the boat, as some of us call it, from PayPal, as I understand, with an illustrious background, including spending time, helping the White House, and very early days apparently in terms of the internet too. So she actually could have retired before now. She had actually bought up all those domain names, right? So can you please put your hands together and welcome Simone.
Thank you, everyone. I wanted to just give a little bit of an overview of the boot camp and what happened and where we're going with it. And then also after that, talk a little bit about Hyperledger, because it's more than you think it is. So with the boot camp, what we did is we wanted to have something where we could get more people contributing to all of our different code projects. And so we wanted to do something that was a little bit different. So one of the things is I've actually been doing hackathons since 2004 and unconferences around the same time. And the way that I looked at it is, how can I merge together some of that energy that we've created before? And so what I did is I merged together the whole idea of an unconference with the whole idea of getting started. And so a bunch of the different projects all came and did either quarter, half day, or full day getting started with a lot of the developers to onboard them. And then they were able to contribute and also test their onboarding process, because sometimes that wasn't perfect. And then be able to contribute to the code bases themselves. So we got a lot of contributors. We got a couple bugs fixed. It seemed like the average person went and got onboarded on 3 different platforms. So that was kind of surprising and phenomenal to me. So it was a huge success, and I wanted to say thank you to all the bootcamp people who also came over here to see this. Oh my God, y'all, Julie and I were just like kind of flabbergasted on the way over here. We're like, oh my gosh, this was like our dream scenario. And I'm like, I know, our dream scenario came true.
We gotta wake up.
We gotta wake up. So thank you so much. Bootcamp was a rousing success. I'll be posting a bunch of those statistics and all of that stuff afterwards. And so one of the things that I wanted to highlight from the bootcamp is the fact that Hyperledger is a lot more than 1 or 2 projects. We actually have a wide variety of projects here, and there's actually 2 that aren't on here. So we have Burrow, which is doing the permissioned contract machine with the EVM. We've got Fabric, which most of y'all know about, which is the larger platform that IBM and others have been working on. We have Hyperledger Indy, who's going to come and talk tonight. I probably shouldn't say this on camera, but they are my favorite.
You're not allowed to have a favorite.
Hyperledger Aroha, that's mobile in focus, and is about to roll out into 1.0 very soon, we hope. Hyperledger Sawtooth, which is actually a lot of the different people that are coming over from India now. And so it's becoming based there. And so we're hoping to have a next boot camp with those guys and some of the other projects, of course, but based in Bangalore. And Hyperledger Caliber, which is mainly based here, and is actually which does the benchmarking. And we're looking at benchmarking things outside of Hyperledger. So helping benchmark others and looking for contributors who are interested in doing that. Hyperledger Cello, which is the as-a-service deployment, Docker Kubernetes style. Hyperledger Composer, which is kind of more for demoing things like proof of concepts, things of that nature. Hyperledger Explorer, which allows you to poke around and view a bunch of the data on the blockchain. It's mainly Fabric though, but it has been upgraded to 1.4, which is their newest release. And Hyperledger Quilt, which is a Java implementation of the ILP, the Interledger protocol. Right now, we're right in the middle of doing a reboot where we're trying to figure out where are we going to take this. Instead of just Ripple, we just, I don't know how many of y'all saw that we just formed an alliance with EEA, where we both joined each other's organizations, and so we're trying to figure out how are we working with the Enterprise Ethereum better. And then two that are missing, one is URSA, which is our security libraries. Very successful adventures here at the boot camp, in that two of the main libraries that we would like to get on is the China library, so that many of these different ones can be run in China, and the Russian. And they actually started working on those different specifications at the boot camp. So, yay. And then another one that was, that's part of the, that's related to the Sawtooth one is Grid, which is the supply chain. So, so many of y'all are probably wondering, why is Indy my favorite? Well, Indy is my favorite because some of the stuff that he talked about that I worked on previously. You might have heard a little word come out saying White House. A lot of the stuff that I started doing in 2004 was working on how do we do federated identity, and how do we do that within government. And it was so funny when I came back over here to Hyperledger from PayPal, and I looked at the Indy project, and I was like, oh my God, these are a bunch of people I used to work with 15 years ago. And we were playing back then with Merkle, we were doing something that was kind of similar to GitHub with Merkle trees and all of that kind of stuff, and I'm like, oh, it's graduating, it's gonna be real. So I'm a little biased, Nathan, and I'm very, very happy with the work that y'all are all doing. And I look forward to hearing your presentation.
So thank you for that great introduction. As you can tell, there's a lot of neat things going on at Hyperledger, and there's a lot of interesting challenges to solve in terms of how the projects are evolving and also how they're converging. Because, like she said, with Hyperledger URSA, we're able to start building a lot of shared cryptography that all the platforms can leverage together. And so a lot of the cryptography code that we've been working on inside of Hyperledger Indy, in order to do zero-knowledge proofs, in order to do some of the privacy-preserving qualities that digital identity needs, are things that we can also make available in a lot of these other platforms. So, one of the unique opportunities we have at Hyperledger is to work across lots of those types of boundaries and barriers to make sure that we have tools that are applicable and useful in lots of different areas, and that they're things that we can reuse, and we can extend the capabilities of blockchain technology into businesses and into all kinds of use cases where previously they had troubles making those types of things work. So I'm here to talk a little bit about Hyperledger Indy, and more specifically around the idea of decentralized identity. You'll often hear it referred to as self-sovereign identity, or user-centric identity, or and there's a lot of different definitions around what constitutes user-centric identity or what constitutes self-sovereign identity. As Selena mentioned, we've been working on this problem for a long time, and there's a lot of people who've been contributing a lot of interesting things. This is a little bit about myself. I'm the CTO of an organization called the Sovereign Foundation. We're an open source nonprofit foundation that's building a global public utility for digital identity. Basically what that means is it's a meta system that sits underneath what you probably think of as an identity system. So if you are familiar with digital identity, you probably have done some work with OAuth or OpenID Connect. Maybe you've set up an Active Directory server, or maybe you've set up an LDAP server, or worked with a business objects database. All of those systems deal with identities. They deal with things that we use in computers to recognize and understand things that are in the real world. Often they create identifiers that allow you to interact with those things, or interact with the other computer systems that those identifiers are attached to. What an identity meta system is it's a system that sits underneath those systems that manage objects and allow them to interoperate or talk one to another. So I work on a lot of things called zero-knowledge proofs. We can see if you have a zero-knowledge proof way of talking about zero-knowledge proofs later, if we have time to talk about it. We can talk about verifiable credentials. So there's a specification that's being worked on at the W3C, which works on lots of web standards. It's the Verifiable Credentials Working Group. We've been working on the specification there for some time, and it's very close to the first candidate recommendation. We also work on protocols for software that represents a user or represents a way of talking to an entity, so that they can talk one to another in a peer-to-peer way that's verifiable and cryptographically secure. And we do a lot of discussion around how to build trust frameworks or governance frameworks for the kinds of credentials that need to flow from one party to another. I would be remiss if I didn't mention that the Sovereign Foundation is a nonprofit open source foundation, and we do have sponsors that help us to be able to come to places like this and to do these sorts of events and boot camps. And these are a few of our sponsors of the Sovereign Alliance. If you like to see us be in different parts of the world and also help your companies with these sorts of presentations or training, this is a way that you can get us to the places where you need us to be in order to help build the ecosystem. Some of you may have seen this cartoon before. If you've been in digital identity, you've probably played all of these roles. And I think we're even graduating now from the ICO for the win category into something that's quite a bit more mature and more sophisticated. But it all started with this thing called the internet. And the internet needed mechanisms in order to identify infrastructure and identify organizations that were real. And so we ended up building out public key infrastructure, or PKI, in order to be able to have certificates, in order to be able to recognize that infrastructure was legitimate. When we first envisioned PKI, we built it so that it actually would do mutual authentication. So that you'd have certificates that identify the infrastructure, but also certificates that identify clients. The problem is, we tied together the key management and the attributes that needed to be bound to those keys. And because we tied those two things together so tightly, it didn't make much sense to try to issue certificates to clients, because you ended up with a big pile of certificates in a browser and you didn't know which places they would be useful for and which places they wouldn't. And end users didn't have a mechanism of managing their keys and keeping them secure over time, which creates the problem that every time any attributes change or any attributes have to be modified, you end up having to go back to some authority to vouch for the fact that this key and these attributes belong together. And so client certificates are famous for being where dragons lie and where you don't want to venture when it comes to web development. But it turned out we had some of those solutions even way back then. There was an alternate spec to PKIX called Spooky, or SPKI. In SPKI, they made a distinction between the attributes and the keys. They actually made it so the attributes were modular and could be bound to or asserted against different keys. But that was just as clunky and had just as many difficulties, because it created a lot of interesting attacks where which attributes should be asserted when and over which keys. We needed some better technology in order to move on and in order to get to something new. Now, this is the logo for the Internet Identity Workshop. This is a workshop that happens every 6 months in Mountain View, California, that has folks from all over the computing industry talking about how digital identity works and how digital identity could be improved on the internet. And you'll notice that its logo is a dog. And on the internet, through the laptop, no one could tell whether it was a dog or not. And when we first got to this construct of PKI and even Spooky, most identity lived in this centralized model. In this centralized model, the only thing that really exists is the organization. They have a certificate. They're authentic. You know that they exist. And then they have a database. And inside of the database, looks like I keep triggering something with regards to the advance here, so we'll see if we can get it to stop automatically advancing on us. But here, we have standards like HTTPS, SSL, and TLS that help us authenticate that the server is real. And then they expect us to hold some sort of secret information. Okay, we'll see if the computer wants to just keep going. I'll have to talk faster so that we can get through every slide before it advances. But you don't exist except for in the server. And if you don't know the password, you're not the person that's the record in the server. And if someone else finds out your password, well, they're just as good as you are, right? And this creates a situation where if someone steals the entire credit reporting index, well, this is exciting. If someone steals the entire credit reporting index, and they know everything about all the loans you've had and all the addresses you've lived at and all the account history that you have, well, it turns out that they're a better you than you. And these services would rather talk to them because they can answer all the questions and you can't, right? It takes you time to gather all that information and remember everything that's involved. So this model has some drawbacks. So let's do something better. Let's make it so that that record that's in one organization can span more than one organization. That sounds like a good idea, right? Now we can triangulate data between more than one organization and we can understand a little bit more about what's going on. So we introduced this idea of an identity provider. And we can federate, meaning you can have an account with the identity provider and then lots of other organizations can all display and talk about what's going on. I suspect that this smart screen, if I get too close to it, is what's advancing the slides. But this also means the identity provider holds and controls all the information. And they dominate that information flow. This can be especially a large problem when you're talking about building identity systems in lots of different places around the world because the companies that dominate these identity providers are not domestic. You don't know whether they're going to be subject to your laws over time or not. You don't know what they're going to do with that information or who they're going to share that information with. I mean, you see breaches over and over again where a company pulls all the data off of your phone and then sends it off to who knows where, right? And of course, it was in the terms of service. Everyone reads those, right? We have technologies that help us with this. We have SAML, we have OAuth, we have OpenID Connect. And in fact, when we built OpenID Connect, it contemplated the idea that maybe you wouldn't want anyone else to be the IDP. Maybe you should be the IDP. But just like what happened with client certificates, we didn't have the technology to make that practical. Because as a developer of a system, you can't figure out how to trust everyone's individual IDP and make sure that they all integrate correctly in your system. Or no one would know where their password should be recovered or who's the custodian of their data. So in practice, these systems lead to a case where either the issuer of the credentials with the IDP centralizes all the data and controls it all, or the verifier of the credentials, the organization, ends up centralizing all the data and the user loses control. So when we get to the blockchain world, something new and exciting happens. This is not the same kind of blockchain we would talk about when we talk about smart contracts, or even when we talk about Bitcoin. Because if you pay close attention, you'll notice that a blockchain can do this type of authentication. In fact, when you think about how Bitcoin works, you have a cryptographic key that represents your balance in a pseudonymous address, and only the Bitcoin network as a whole manages that account information. So it really is a centralized digital identity system from the standpoint of every address has one balance. Now, thankfully, because it's a decentralized system, you can have plenty more than one address. But if you transfer balances from one address to the other, it's traceable on the centralized system, right? Creates some interesting considerations. We also have a lot of blockchain identity solutions that try to build federated solutions, where as long as you use the federated service, they'll validate that this is a real person, and you can use their federated credential everywhere within the blockchain ecosystem. But blockchain makes something possible that's much better, which is instead of having an account with a system, we can now have a connection. And when we mean a connection, we mean that you have an identifier and you can be publicly known and verified, and I can have an identifier and I can be publicly known and verified, right? And this means that I can authenticate you and you can authenticate me. which is very convenient because instead of just knowing whether you're talking to the real bank's website, the bank can know if it's talking to the real you, right? And that means you can gather data from both directions, and not only can the server store information about you, but you can store information about yourself. And that makes something very interesting possible because now, instead of holding all that data in their server, they can give it to you. They can sign it and say, here you are. This is one of the ways where we say it's a user-centric system because the user is actually one of the nexuses of the data that is exchanged. And then you can present that information back to them and they can verify it. So even if they don't want to store the data, they can still validate that it's authentic or that they have verified it back in the past. And even that's enough to create a lot of interesting things, right? We now have secure messaging that can be happening peer-to-peer. We can give you information and we can get it back. But what makes it even more interesting is it's not restricted to a single peer. A decentralized system allows anyone to write, which means that anyone can be a peer in the network. It's not just about servers, it's not just about clients, it's about connections, and it's about the data that can be shared across a relationship and then be shared beyond that relationship. So we need some specifications to help us build this. First, we need a way of identifying all the parties in the system. Some of these identifiers need to go onto a blockchain so that everyone knows about them. Some of them just need to be shared peer-to-peer so that I can create a connection and we can talk over that connection over time. We call those decentralized identifiers, or DIDs, and this is one of the specifications that's being worked on at the W3C underneath the Credentials Community Group. The Credentials Community Group is open access. Anyone who chooses to can join the Credentials Community Group and participate in the development of these specifications, especially the DID specification that's being launched into a working group soon. The second specification we need is now that each side has cryptographic keys, they need to manage those keys. It doesn't do us any good to give you a cryptographic key if you're going to lose it and have to re-rotate it and change it all the time. So instead of tying the keys to the attributes, we now add a third layer to the abstraction. We now have attributes, we have cryptographic keys, but we also have persistent identifiers. So a decentralized identifier provides us with an identifier that can then have keys attached to it, and the user can now rotate and manage those keys over time because attributes are not issued to the mechanism you use to communicate, they're issued instead to the wallet of the individual. And that allows us to assert credentials over time against any of the identifiers that we're using. So when one issuer gives me a credential, perhaps my bank gives me a credential that I have a bank account, I can then take that credential and present it somewhere else to prove that I can purchase something, or perhaps to prove that I'm creditworthy in order to receive a loan. The third step that we need to talk about is when we have one of these peer connections, we need to validate that it is authentic. We need to know that your key is correct and that my key is correct, and we need to be able to use that to validate other kinds of communications. For instance, it would be very nice if we didn't have to use a password anymore. It turns out that the DID authentication spec has a lot in common with the WebAuthn spec, and we're investigating right now how the overlap will allow us to share lots of different kinds of information over channels that can be secured by hardware tokens and the things that are covered in the FIDO specifications under U2A and UFA. And then last, we need a specification for these credentials. We want to make sure that these credentials can flow from all kinds of ecosystems into all kinds of other places. The Getting Started guide that we usually use in Hyperledger Indy has a hero named Alice, and she gets a government ID, and then once she has a government ID, she applies to college. She graduates from college and gets a transcript from her university. She uses the transcript of her university to apply for a job. She gets that job, and then she uses the fact that she has a job to apply for a loan. And you can see how one set of credentials almost always leads to another set of credentials. And when we have a multi-sourced identity system where everyone's a peer, we can allow those credentials to flow in an automated way, so we can reduce data entry overload. We can also make it so that systems that previously were siloed and independent from each other can have information that flows from one system to another. And this is very important when we talk about establishing identity in lots of different places around the world, because there's not just one root of identity. How do you know that I'm the real Nathan George? Right? No, I came here, and I guess I had some biometric data. There was some biometric data in the posters that were on the wall, right? Salona vouched for me, right? Julian vouched for me. So there's multiple sources of authentication that you're trying to draw on to establish that my identity is real. Now, I didn't get out my passport and show it to you, right? That's a different source of identity, right? In in most interactions, we don't use what we think of as traditional routes of identity to validate trust. And what this really means is in the real human world, it's not about having a username and a password in a single system. And it's not about direct point-to-point API communications. It's about asserting an aggregate of credentials from multiple sources in order to gain the trust we need. And so when we have a multi-source identity system, it allows us to draw on the same multiple types of trust that we do in the real world today. And this is what allows us to model things in a more similar way to how law has been structured and how the precedents have been structured before we entered the digital age. We don't have to tailor our regulations, our rules to the technology. We can tailor the technology to us. We can be more human-centric, and we can match the expectations we have as societies in terms of how we expect the system to function. The sovereign network is designed with some really particular points in mind. The sovereign network is the network that uses the Hyperledger Indy code to deploy a globally interoperable network. We have a strongly known validator pool that consists of nodes that have very different qualities. We try to pick the most diverse set of nodes we can out of all the stewards from around the world. And because it's a strongly known or permissioned set of validators, they can all sign every bit of state that's put onto the network, which means that the network provides the service of notarization and also immutable storage so that credentials work across any peer that might encounter them. That's what means that the holder is actually in control. The holder of the credentials can show those credentials to whoever they would like, and they can validate that those credentials are correct without having to do any direct interaction with the issuer. Then we have an observer node pool. Almost all of the credentials interactions happen off of the ledger. None of that critical data should be stored on the ledger at all. The thing that's stored on the ledger are the correctness proofs. That way you have horizontal scalability, and anyone can get a copy of the ledger to service the read requests that they need to service. So you don't end up with a blockchain that is the bottleneck to the credentials flows. And then finally, we end up with this outer ring, which are the pieces of software that represent the different wallets that need to store data. Now, we call those agents because they have a fiduciary responsibility to the person that owns and controls their keys. Those pieces of software don't work for Apple. They don't work for Microsoft. They don't work for anyone but the identity owner themselves. Now, obviously, if it was Microsoft's wallet, then it would work for Microsoft. But if it's the wallet that's on your device, that's on your phone, or that's for your business, that wallet reports to just that business. It does the things that they authorize for it to do. So when we think about what goes on the ledger, it's actually relatively little. We want the ability to say, hey, I've never seen this identifier before. I need to ask them for proof. I don't know anything about the Utah Driver's License Authority, and Nathan just showed me his Utah driver's license. So I need to go back and look up their identity agent and say, can you prove to me that you're a driver's license authority? And I need to walk that chain of proofs until I can trust that it's a credential I can use. Second, when I see one of these credentials, I need to know what the issuer meant. Did they sign this credential because it's a driver's license? Or is it simply a voter identification card? Or maybe it's some other form of government ID I've never seen before. I need to know what the issuer meant when they signed it with their cryptographic keys. And then I need to know that the attributes in that credential are correct. I need to be able to validate the cryptography that's present. And we use the credential definition to do that. And finally, I need to know whether the issuer has taken it back. Maybe they issued the credential in error. Maybe they don't believe that I'm licensed to drive any longer. I need to be able to check that the credential has not been revoked based on information that's on that public oracle. And that gets us to a ledger that can act as a root of trust. It's not a source of truth. We haven't centralized any of the data on the ledger. Any issued credential doesn't exist on the ledger at all. All the credentials exist out in that agent ring being exchanged peer-to-peer over these secure connections, which means that we end up with a cryptographic trust layer that lets me say, is this credential real? Is this what the issuer meant? And is this data revoked? That we can use to build a layer of human trust. The layer of human trust lets me answer questions like, is this a real DMV? And I do that by using multiple pairwise relationships. The issuer and the holder have a relationship. So a driver's license authority could give me a driver's license. But then where I present that driver's license or how that present that driver's license is then up to me. And I can selectively disclose the individual attributes in that credential to the different agencies or organizations that I want to show it to. I don't know if this is the case here at Hong Kong University, but at the university that's nearby where I am, Brigham Young University, they issue identification cards to all the students. And those ID cards say right on them, it's only for school or educational use. But it turns out if you go to the local sandwich shop, they'll give you a discount on a sandwich if you have a university ID card. Now, did the university authorize that use? Would you like it if the verifier went and asked the issuer, hey, is he really a student? Is he current on his tuition? I'm not giving him a discount unless he is. Right? We laugh about that because it sounds ridiculous. When we think of the things we have in our real physical wallets, we carry around these credentials because they represent the relationships we have that we can prove something about ourselves to others. Right? And the important point here is that it's not a three-party relationship. They're not trusting the university, they're trusting the data you're willing to disclose to them that the university has signed, right? So you have a pairwise relationship with the university, and then you have a different pairwise relationship with the sandwich shop. And the sandwich shop has this transitive trust relationship back to the university. They understand that university students eat a lot of sandwiches. And if they can get you hooked on their sandwiches, you're gonna bring all your friends and you're gonna eat more sandwiches, right? It's not about what the issuer authorizes. It's about what the holder and the verifier are willing to trust collectively. Digital credentials can work exactly the same way. And when they do work that same way, it means we can take high security credentials and we can selectively disclose much less information to allow them to function in low security contexts. We can also take lots of low security credentials and we can use them in place of high security credentials when they are not available. And this makes it so that the whole system works much better because when an issuer won't cooperate, you can find substitutes. And that means there's a market dynamic that makes it so that neither the issuer or the verifier can centralize all your data or take control of your identity. And that change in how information flows creates dramatically better dynamics on the internet than what we would see with just a federated identity solution. Because when the issuer and the verifier have to talk directly to one another, whichever of the two has more market power ends up centralizing all the data and taking control away from the holder. Not because they're malicious, but because it's convenient in terms of cryptography. Because when I present an access token to the holder, I give them less data, and now I reduce the chances of a multi-presentation attack where you can compare the ciphertext and the plaintext. And so it's simply a technology reason to say, no, don't have any of the data, just take the access token, and then they'll go back to the resource server and get the resource directly from the issuer. But it means now the issuer can do real-time correlation, and they know all kinds of information about you that were not pertinent to the use case at hand, right? And now the holder's not party to what data was actually shared. Instead of knowing that you only disclosed your student ID, that you had a student ID, now they might be going and retrieving the entirety of your university transcript. You know, if you're in the law school, they're not giving you a discount for the sandwich, for example, right? So we don't want to create cases where people can collude. We want to create cases where each party has the right kind of authority to keep the market balance. Issuers are in charge of what they're willing to sign. Holders are in charge of what they're willing to share, and verifiers are in charge of what they're willing to trust. And when all those parties have balance, more information can flow. And in fact, you can share more information than you could otherwise. We use a technique called a zero-knowledge proof to make it so that then we can selectively disclose the subset of the credential to the party in question. And that allows us to compose credentials from multiple sources to prove things that we couldn't prove previously. And because you're using pairwise identifiers with unique unidirectional IDs, I know that that data stays within the connection because I'm proving it in zero knowledge and I'm proving it only across the pairwise identifiers. And that means I can actually share more than I used to be able to share. Now that said, there are some things that are very dangerous. When you go look at decentralized identity systems, watch out for these things. If people are using a universal identifier on the ledger and saying you need to have one identifier and we're going to prove that you have one identifier, or they're saying let's cross-sign the credential with a unified or single identifier, that system is going to betray you in that the issuers and the verifiers can now start to collude and they can disintermediate you from the connection. That trust triangle we talked about with 3 pairwise connections becomes a trust love triangle where they're going to box you out and take your data. The one identifier to rule them all problem, right? Where if no one has actually one identifier. In the United States, in our medical record system, we have a federal mandate that says you can't have a centralized identifier issued by the government. And so as a result, every facility has their own facility patient identifier ID. And then they take about 18 points of personal information and they use rules to match to see if you're the same or you're not the same. It turns out that there's one hospital in Los Angeles that has over 1,000 Maria Garcias. So if they're using first name, last name, and birth date, how many duplicates do you think they find? It turns out we kill people thinking that we have one identifier to rule them all. Because we merge people that shouldn't be merged, we split people that shouldn't be split, and then even if you think you have one identifier, the answer is it's all lies. You mostly have one identifier. And so by matching the fact that credentials are unified and coalesced around a wallet and proof of possession, we change the nature of how we do identifiers to understand that there is never just one. Now, it's still the case that you have identifiers in a database. You might have a driver's license ID, you might have a passport number. Think of those as attributes. And those are attributes that can be used to correlate and tie things together, but they're not identifiers that you want to use to prove possession of something cryptographically. Next is the idea of negative reputation. It's very easy to prove something exists cryptographically. It's very, very hard to prove that something does not exist. So please ignore people who say, I can give you proof that I'm not a criminal. Right? Or if someone would never disclose proof that they are a crook, right? Instead, you want to make sure that you model positive reputation so that people who have done something that they want to disclose have incentive to disclose, and people who have not done the same thing do not have that same capability. And when you model it that way, it allows the physics of information sharing to match, because what has been seen cannot be unseen, and what you know, you can't force someone to disclose. You can only incentivize. Finally, metadata is data too. There's no such thing as data about data. It all creates correlation, and it's all something that can be used for record matching and can be used to link things back together. So when we talk about what data gets stored on a ledger, it's very important to think about the consequences of how you store it. And that leads to the idea that an identity network that supports everyone in the system is not something that tells you who you should trust or who you shouldn't trust. It's something that tells you who said what. And then it's up to you to decide whether that person should be allowed to say it. If I issued you a credential that said you were a medical doctor, you could present it to a lot of people, and they shouldn't believe you. Because I don't license physicians, right? I'm an expert on digital identity and blockchains, not an expert on who's a good neurosurgeon. So that means that we want to build trust frameworks that allow us to interoperate. You're probably all familiar with at least one trust framework because your credit cards that you carry around in your pocket have been doing trust frameworks for a very long time. We have lots of trust frameworks in law, and we have lots of trust frameworks in the physical world. When we have digital credentials that match what happens with real physical identity, like what we can do with a connection, all those same things we've learned from those trust frameworks are directly applicable to digital credentials as well, which actually makes the problem easier. And that's really the essence of what we're trying to build with the Sovereign Network, which is built on top of Hyperledger Indy, and all the technology is available as open source inside of Hyperledger, is we're building a backplane that's usable to make those credentials flow from one place to another, so that the credentials that you use from one issuer, you can then leverage and make portable the reputation with the other issuers that you deal with. And we really strongly believe that this will change a lot of what we can do. It means that we don't have to have passwords. It means that businesses don't have to store all your data. It means that we can move to systems that can process things anonymously, where now businesses are sitting on large piles of information that turns into a liability. Just like they want to know more about their customer, and this allows them to have a better direct connection with that customer, and allows them to participate in a way that adds more value and reduces the risk. And that's really what we're trying to build with Sovereign, and that's why it's so much fun to participate at Hyperledger with all the technology that we're able to play with. So with that, I think I'll turn the time back over to our gracious host.
Great. Well, can you open your hands?
Thank you so very much for that, Nathan. I mean, as you can hear, it's just wonderful there. So maybe what we were planning on doing was perhaps have
A little panel, maybe.
invite everybody else, and then open it up to the floor for your questions.
Well, I have a few more people. Bawa, you going to come up? Where is it? Yeah, you come up here. And anyone else? I think Eddie, you should come up as well, right? You sure? Okay. And maybe anyone else? Huh? Dave Husby?
Yeah. I'm here.
There you are. It's always hard to see it. Blend it into the background.
That's what my security person is supposed to
Exactly.
do.
Before we get to the questions, maybe you all explain who you are. Should we? So yeah, let's switch.
There's a microphone right here on the table as well. If you want to pass it around, and then anyone who's sitting behind the table, there's a microphone here that can be used.
Yeah.
Sorry about that.
So we need to do a self-introduction.
Yeah, self-introduction. Basically, the key thing at Tabawa is that there's always one of the things. It's part of our technical steering committee, right? Well, the heart and soul of the Hyperledger project is the technical steering committee. There are 11 people that are voted in by most of the people, the committers and maintainers. We have 2 today, Nathan and Bawa. So give a little introduction, please.
Hi everyone, my name is Bao Yang. I'm a principal architect in Oracle now. I'm leading the blockchain product development. And I have been within the Hyperledger community for 3 years. I'm also the code committer for Hyperledger Fabric, Hyperledger Cello, and maybe the other projects. Also, I have been one of the TSA members since last year. It's very glad to be here today, and I'm open to any questions. Thank you.
I'm Dave Huseby. I'm the security maven at Hyperledger. I'm fast approaching my 2-year mark with Hyperledger. I think it's like a few weeks away. I am in charge of all of the security-related things about our software delivery. So I work with our projects around issues of software quality. I run our outside security audits, our bug bounties, all of those things. But I'm also one of the founders of the Hyperledger Ursa project, which is a cryptographic library abstraction that is going to allow the Hyperledger blockchains to adopt cryptography from all over the world. So like the SM crypto, the GB crypto from China, the Ghost crypto from Russia, the FIPS crypto, the United States government, and then all the open source crypto as well. So it's not targeted specifically at Hyperledger projects, but I think hopefully all of our projects will adopt it as well as others actually. I went drinking with some Enterprise Ethereum Alliance people last December, and they're interested in it as well. So hopefully that's where we're going to go with it.
Excellent. The other person, actually, Victor, why don't you come up as well? Victor's the leader of the Caliper project, right? Introduce yourself.
Hey guys, my name is Rico Hu, and also known as Victor. And I'm an engineer from Huawei, and I have been working with Hyperledger community for like 3 years. And currently I have been working with Caliper project, but I'm not a maintainer, and I didn't make a lot of code contributions, so I'm just helping the project and the community to make it grow better. Okay, thank you.
Yes.
It's very modern.
And I'm Julian Gordon. I'm the VP for Asia Pacific. I'm based here in Hong Kong. Actually, I was born in Hong Kong. I've most of my life in Hong Kong, and I help the community anyone get involved in the community, get involved in Hyperledger, an open source community, so we welcome anybody. So please ask me, and obviously Evelyn, I work with here in Hong Kong, to basically manage and support the community across Asia Pacific. So I think we're going to have some questions, but first I want to ask Brian, right, because before we had discussion. So Brian, why are you interested in this subject, right? What's the basis of your interest? And then we'll go to questions, I think.
Super, thanks so very much, Julian. Well, my background is really in corporate law, and I, from big law in New York to big bank, and then into startup land. And really, you know, when you see how technology is intersecting with so many aspects of society, whether it's in finance or fintech, or legal tech and law tech and reg tech, really, you really need to understand the different kinds of emerging technologies that are coming aboard. So I was tapped to lead this new initiative called LIGHT, Law, Innovation, Technology, Entrepreneurship. And so there are so many ways in which law intersects, and this was an opportunity, frankly, to allow the technical fraternity to better understand some of the legal elements, right, and why it's important, and vice versa. So there are too many lawyers that actually, so I organized, for example, you know, Hong Kong's first legal tech and reg tech hackathon. So very often it's the first time a lawyer has been to a hackathon, right? And we're trying to raise that awareness and build the community together. So especially when Edmund reached out to me, and I learned that it was Nathan that was coming, you know, talking about sovereign, which I had heard of from before. And then afterwards I had heard him at Blockchain Week. It's so important that we have the caliber of people who are coming through Hong Kong, and it does happen quite a lot, that we give this opportunity to the community, especially the student and community to learn and hear from. So thank you so very much for the opportunity to host you all, and thanks so very much, Nathan, for your fantastic sharing.
All right, excellent. Any questions? All right, I'll carry the microphone.
For by the way, the United States doesn't have uniforms, but my kids went to school in Australia, and the zero knowledge proof in Australia to get on a school bus or to get a discount at a center shop is your uniform. If you rock up in a uniform, you get on the bus, you get your discount at the local sandwich bar. So it's even easier. But the real question is, 30 years from now, 20 years from now, when you have functional quantum machines, and somebody digs up an old version of your blockchain and cracks all the elliptic code keys.
I can answer this.
And he's going to swipe this.
If you put any of that on the blockchain, I will find you.
And then I'll punch you.
So the answer here is any correlatable data has no place on the chain. The thing that goes on the chain is the verification data. And that verification data is only to verify the issuer, not to verify the individual credential. So when I get a credential, that credential is self-contained for me to say, according to the oracle on the chain, is it valid from the issuer? But all the attributes, all the things that are in your credential, none of that ever touches the chain.
I've hacked the bank and I've got their old database now.
Okay.
Exactly, and so the idea here is because the identity agents are where all the data is stored, and we'll jump back to the, where is it, the 3-ring model. I have too many animations in this slide. There we go. Because all of the important data is stored out here in that orange ring, if you discover any vulnerability, you can turn the agent off. The data is only shared in real time. Remember, we're proving things in zero knowledge so that the proof is not transferable. This is the quality of zero knowledgeness in a zero knowledge proof, is that I'm proving it within the context of this one interaction. And going forward, I no longer know whether revocation is true or is not true. So if I discover that there's a vulnerability in the network itself, meaning quantum computing has broken all of my cryptographic keys, I just push the red button, agent off, and then I'm going to wait until I have a safe way of rotating my keys before I turn it back on.
I'm saying going back to a 30-year-old database, which is a good way to find out someone's hacking now. Now I've hacked Amazon, I've hacked the bank, I've hacked the local. That information is all out there. I just need to cross-correlate, which is effectively a key overuse scenario using data. Now I can identify you 20 years from now, which is a good way to identify you. If I identified you 20 years ago, I can figure out who you are now.
So
this is of course the extreme scenario, but when you're going to ID the whole world, are we setting up a scenario where one dictator can?
Yes, and there's two parts to this. Dave's going to answer the first one. I think I have the second one.
Okay, yeah, so the first part here is that you may be able to break the encryption, but the encryption's not going to reveal any data because that's what Nathan's saying. It's not stored in the blockchain. Okay, there's a protocol that I helped define earlier this year, or last year, I guess, about what happens when we find out there's a quantum computer. Okay, this is actually one of the reasons why we're starting the Hyperledger Ursa project, right? We actually have a protocol where you take an existing blockchain, that has been using cryptography that can be easily broken with a quantum computer. You take all of the hashes from those and you build a Merkle tree up, okay? You hash the Merkle, or you sign the Merkle tree using the pre-quantum cryptography. You also sign it with the post-quantum cryptography, and you record all of that in a single transaction that not only ensures the integrity of the previous data, but also reconfigures your blockchain to use the post-quantum cryptography, okay? That's all you actually need to ensure the integrity of the previous data. Because yes, the pre-quantum cryptography can be broken and you can rewrite it, but the fact that that root of the hash, right, that covers the whole previous blockchain is also signed or encrypted by the post-quantum cryptography, which cannot be broken. You can also ensure that the integrity maintains itself across that boundary, right? And all of the Hyperledger blockchains can change potentially can change the algorithms on the fly by recording a single transaction in the blockchain that says, we're now switching from pre-quantum to post-quantum, okay? To achieve that, we need an abstraction of the underlying cryptography that the blockchain uses so that we can have two implementations of the cryptographic primitives present. And so when you tell the blockchain, okay, now we're going to start using, lattice signatures or something that's post-quantum secure, the actual software just switches. Okay, we're not using this algorithm now, we're using this algorithm now. So that's actually one of the three main reasons why Hyperledger exists. There's two other reasons, right? But you combine that with what Nathan's about to say, and you actually don't expose yourself now, the data that's being recorded and tracked now, you're not exposing yourself to future attacks in a post-quantum world.
If you're a student who's interested in identity, especially digital identity, I strongly suggest you go look up Kim Cameron's 7 Laws of Identity. If you haven't read that paper yet, you should. And one of the core principles inside of that paper is the one that I put up on the screen here. And that is a solution that discloses the least amount of identifying information and best limits its use is the most stable long-term solution. And it's for the exact reason that he described before we went into the cryptography, which is every piece of information that you disclose is potentially a correlatable pivot point. And cryptographic keys make it so that you know whether data is authorized. They do not control whether the data is known, right? And that's a very important distinction. If you prove something to me, I could go out in the middle of the hallway down here and I could shout it to everyone, right? And I can do the digital equivalent by tweeting it out onto Twitter, right? So what the cryptographic keys do is it means, are you the authorized holder of this? And can you prove that it was given to you with consent? Because when we split apart the credential from the proof and we have a different cryptographic construct for giving someone signed data as we use for proving that data, it means that we have physical mechanisms of saying, did someone share this with you with the intent to reshare? Or did someone share this with you only with the intent for you to see it? And that means we can make our business rules and our legal rules match the intent that the user had when they leveraged the cryptography. It doesn't mean that someone couldn't still betray you. And so you want business and legal rules that help to enforce that, and different governance frameworks are going to have different requirements. But the most important thing here is we need to minimize the data flow. If we don't, this digital credentialing system leads to the information apocalypse instead of the information freedom that we want to have. Because we want to make it so that each party has their own consent and control and can share more data with more people. But if we then turn around and say you need to fully authenticate every piece of data you can possibly have every time you interact, well, that turns into something out of a dystopian science fiction novel.
Yeah, I think that, to move away from the quantum attack, right? I think we've explained that there's ways to defend this. I remember when I first met Nathan, I still owe him an apology. I haven't apologized. But I cornered him and I said, you're doing this all wrong, right? I did this. And I was terrible.
Public apology now,
yeah,
right?
I was terrible, Nathan, because when I started working at Hyperledger,
will you sign this apology?
with the verifiable signature.
Yeah. I had just come from Mozilla, so I was one of Mozilla's my job literally was to figure out how people are tracked on the web and how to defend it, how to defend Firefox users from tracking. Okay, and I went for 4 years and developed this way of describing the information that you put out onto the web and the severity of that information. So it's not only what information you are and how much information is in it, so like what your screen resolution is or what hardware in your computer is, but there's also this longevity sense, right? Like how often do you change the graphics card in your computer? You do it maybe every other year or whatever, right? How often do you get a new monitor? Again, probably every couple years or something like that. So they have lifespan. This kind of data has lifespan, okay? And it only takes, there's actually math behind this, but it only takes 2 or 3 of those things that they can measure about you, what the display resolution is, what your model of your graphics card is, what your operating system is, what version of your operating system is. It turns out there's about 38, there's probably more now, but there's about 38 things that a web browser readily gives to a web server whenever you go there. And actually you can get more if you run certain JavaScript. Like when you go to a web page and it says, hey, this wants to access your canvas data or your HTML5, what they're actually doing is they're rendering fonts into a canvas and then measuring the widths of those fonts because that fingerprints you, right? And there's not a lot of data that needs to be gathered to uniquely identify you from every other human on the planet. And it applies across all web servers on the internet, okay? So this is why I tackled Nathan. I was like, look, you're doing this all wrong. There's all these correlating factors. And it really boils down to every interaction with another party. So these are those pairwise things. They either have to look identical to every other action of every other pair of people on the planet, which is essentially impossible, right? Because that means that all we can ever do is just say hi to each other. And that's the only other thing we can do, right? So they either look exactly the same or every interaction between any 2 entities on this planet, organizations, people, has to look unique, has to be different. Okay, so you can't take any 2 interactions and say, okay, these are both Dave, okay? And I think what Nathan was trying to get here was that like, this whole system allows that to be possible. So when I talk to you, okay, my name's actually Bob, okay? My name's actually Steve. Now I'm Tim, okay? Now the 3 of these guys get together and they go, hey, yeah, we just had a conversation. He's like, oh yeah, I talked to Bob, Steve, and Tim. And they go, oh yeah, okay, there's 3 different people. They don't know that they're all me, okay? And this, I'm trying to get back to a salient point here, but when I tackled Nathan, it was just like you gotta make sure that there are nothing that has like a long span of a lifespan, right? It has to be something that continually changes. And what Nathan, I think, is getting at is that we're able to roll keys pretty often and actually have a generic, or a unique identifier, unique pairwise relationship between anybody in these kinds of systems, right?
Well, and this is where I'm going to appeal to Kim Cameron again. The next law of identity is justifiable parties, which is digital identity systems must be designed so the disclosure of identifying information is limited to parties having necessary and justifiable place in a given identity relationship, which is exactly the example that Dave just described, right? Because he used a pairwise contextual identifier with each party, they can't collude and include a non-justifiable party in the relationship, right? But this means that you end up with this really gnarly graph transformation problem where the data you share with one person has a different set of identifiers than that data you share with another. And that means that you are in control because you're the only mapping of that graph transformation.
There was a pet issue similar to that in Korea 2 years ago. But it was using Steve Gibson's early protocols after he went on. I don't know if you're familiar with Steve Gibson's protocols. But fancy Kim K saying anything as profound as that. I always thought Kim K was stupid.
You want?
No, I'll let somebody else ask.
But I should say that when I did tackle Nathan and say you're doing this all wrong, he explained all this to me, and I very humbly said, okay, you're not doing it wrong.
But you might agree.
I had made a mistake. I misunderstood what was going on.
Any other questions?
Can I ask this question?
Shall I take the microphone back?
Yeah, go for it.
Yeah.
I was afraid I won't be loud enough for you guys to hear me. First of all, I want to thank you to Andrew, the speaker. And this question is actually for you, team guys, all together. See, two parts of the question. If we go back to the very beginning philosophy or logic, will you call it a disruptive-based thing to set up this, work out this solution, or is pretty much out of a compromise that you have to do to the existing systems, philosophical and methodologically? And then in the real solution for R&D side, on the application view, where are we now? Are we in a theoretical developing thought map stage, or do we have a user case? Or, because if we try to get a user case, I get a little bit confused, or actually I need you guys to clarify in terms of that proof, see? Pre-quantum, post-quantum, and between that, you seem to give a socket, if you may, I use the word, to try to certify, the things which happened before that. And, by means, technological means, I'm not quite sure about, if you still call it blockchain, I understand your purpose of protecting the idea, I fully agree with, but there are two fundamental disputes or problems with the blockchain, right? One is you want to make it centralized or decentralized. So the things that you guys are doing for certifying the thing, do you need a third party to chip into that, which is your solution, or do you want the framework and the system to do it automatically? Yeah. And if you wanted to do it automatically by algorithm, pretty much, there's lots of AI rules that you have to deploy. There are lots of data you have to train. Yes. Where are we now, technologically as well as feasibility-wise? Thank you. Apologies for the...
No, that's fine. My first answer to this question is that any of these frameworks has at least three components. You have the business rules, the legal rules, and the technology rules. And if you try to optimize too heavily to one or the other, the system will fail. You need to have equal parts of all of them. And one of the things we've seen, especially in digital identity systems, is folks have over-optimized the technology side. And it means that the practical reality of how credentials are issued and trusted are ignored, and then the system isn't useful. So you have to have all three elements. And I believe myself that if the system is disruptive to what humans naturally do, it's unintelligible and it's mostly useless. So in terms of how humans interact, it needs to match the patterns that we've been using prior to digital and the patterns that we have aside from digital. Now, I don't know that that answers your question fully, because you still have to resolve all of the issues about post-quantum computing and how to make sure the cryptography works properly, and how to make sure that verification can happen at a distance. And those are all going to continue to sound complicated, and we'll talk about a lot of things like blockchains and hashes and Merkle trees and ZK snarks and all those sorts of things. And I think that's okay. But ultimately we have to remember that we need to solve a real problem for real people, and if we don't do that, it's all just an intellectual exercise.
I think what's most interesting about the sovereign network is building, and other similar decentralized identities, but very specifically the sovereign network, is that it probably most closely maps to how humans work already, how our society works already. Because what's going to happen if sovereign is successful, and they're already getting to this point, is that organizations that issue credentials already, universities issue diplomas, right? Governments issue driver's licenses. They will become roots of trust on this network. They will just join, and this is just one more form of the credential, right? Instead of giving you a little card or a piece of paper, they're issuing you a digital credential that is much more portable and doesn't necessarily have to be copied and given. Like, you don't have to show somebody your ID anymore that has all of your information on it. You're now able to do zero-knowledge proofs. So I don't have to tell you my name or my age or where I live or any of that information, but I can prove to you cryptographically that I have a degree from the University of Washington in software engineering. Okay, so I can apply for a job and I can say, yes, I meet the minimum qualifications because I have diploma from a university that's accredited, but you don't really need to know anything about me other than that, right? I can very selectively disclose this kind of stuff. And I have a feeling that as this rolls out, most people who are not sophisticated, who don't know the details of the technology, will look at it and go, yeah, what's new, right? Instead of being a card in our wallet, it'll be an app on our phone. And instead of showing, you know, like I go to a bar and they want to make sure I'm old enough to buy alcohol, instead of showing them an ID, they scan a QR code on my phone. It already maps to the existing systems. It's taking all these physical credentials we have and just making them digital.
Maybe if I can add to that, but also I maybe clarify Margaret's question a little bit, if I may. So I think part of the question is asking how far down the track is the prototype, right? So how functional is this? So how much is aspirational versus in the roadmap, and where you are on the roadmap? So I think that's one part of it. And the second part is, again, we're legal background. So part of it is within the area of eKYC and eID, there are lots of utility solutions being proposed, all of them centralized, by the way, right? And even then, it's governments, and some governments and regulatory authorities are having difficulty accepting a centralized utility approach. Whereas right now, again, in my world, banks are all doing KYC separately. And they're saying, well, doesn't it make sense to just have a centralized utility? But even then, that's a hard sell. And then you're selling one step further. Oh, we're going to decentralize it, right? So would love to hear your thoughts in terms of that journey and the challenges and how you hope to overcome some of that.
There's a lot of aspects to that question. We do have a few minutes to cover it. First off, when we think about a credentialing system that's decentralized in this way, it's not the identity issuer system that's being decentralized. It's also not the identity issuer system that's being put on the blockchain. It's actually the meta system that sits below it. And so the government issuer, the one that's issuing the identity cards, or the one that's doing the eID initiative, actually doesn't change the nature of their system. They're still fully in control. They still issue identity cards the same way they've been doing it in the physical world for a long, long time. And they understand the idea that our cards are special. They have to have special watermarks and special integrity devices to make sure no one can fake them. And all we're saying to them is they're doing that exact same thing digitally. And those watermarks, those anti-counterfeit measures, are just using the cryptography that we know about for a long time. But they gain some interesting superpowers, right? Instead of just having a card that you physically have, they have a card that they can revoke, right? When your driver's license expires, no one really knows. You can go and still show it to people, and they think it looks valid. With a digital credential, they can revoke it at a distance. And so it makes it so information flows can happen more quickly, and it makes so those proofs can also happen at a distance, which takes the existing system and simply extends its reach. It doesn't change its fundamental nature. And so the hope there is that as we pursue these eID initiatives, we can help those systems understand that this is not the revolution that they've been afraid of. This is actually an extension of their authority that they've had all along. And this is the kind of system that will preserve that authority, because it makes their credential interoperable the same way the physical system has been interoperable all these years. Because you could always present your driver's license to several different organizations and they could verify and validate it, right? And the driver's license division, the government issuing authority, didn't have to care. And they could change that system and break everyone else and laugh about it, because they've said all along, we're the issuer, this is the credential, if it's useful to you, that's great. And if it's not, we're sorry, this is what we issued it for, right? And with a credentialing system that allows the issuer to remain in control of what they're willing to sign, the holder in control of what they're willing to share, and the verifier what they're willing to trust, it actually matches the physical identification systems we've had all along. So the hope is that yes, it is revolutionary technology, it's doing a lot of things in a new way, but it's doing it in a new way so that we can continue to do it the way we've understood it.
I should also point out that by making things more efficient and digital, it's actually going to make things easier on a lot of parties in these interactions, okay? So the story I tell people that really kind of, I don't know, the reaction I've gotten is like, oh my gosh, I've never thought of that. When you go to an online store and you want to buy something, usually you have to give them your name, your address, your payment information, all of that. You have a lot of data entry to do, okay? And there's some statistics out there that it's somewhere between 10 and 20% of online interactions fail because someone mistypes their credit card number or they mistype their address. And in the best case scenario, the server does some checks and is like, oh, that's not a valid address, and then it goes back to the customer and says, hey, let's fix this. But a lot of times they're not able to catch that, and they ship it off to some random place, and people wonder where the stuff went, and so there's a lot of loss and inefficiencies in the system. With something like this, right, with the negotiation of what I'm willing to, like if the verifier is willing to accept, what I'm willing to present, and all these things being automated, I can go to an online store, choose something to purchase, and we can automate the process of purchasing that because I can tell the retailer, you don't need to know anything about me. Here's a verifiable proof that my bank has actually KYC'd me because I'm a customer. They've actually seen me physically. They've looked at my, all their things they need to do to verify I'm a person and I have an address and I'm in this, all those rules. Okay, so I hand that to the retailer, like, you don't need to know anything from me because, this bank knows everything about me, knows that I'm a person. And you don't need to know any payment information because I'm a customer of Visa or MasterCard or whatever payment or this bank, okay? And here's also a voucher for collecting payment, okay? You also don't need to know where I live because here's a proof that I'm a customer with FedEx or I'm, a citizen of this country that has a postal service, whatever, and the shipper knows where I live, okay? And here's also a voucher for getting a shipping label to ship whatever I just purchased to my house, okay? So now as an online retailer, I have all these proofs that you're a person, you can pay for it, and you can receive a package, and I have two vouchers that I can use to collect payment and also to get a shipping label that you've paid for, that the consumer has paid for. So this drastically reduces the amount of fraud, drastically reduces the amount of errors, streamlines the whole process for everybody involved. And the best part about this then is that the online retailers no longer know anything personal about their customers, which also frees them from the risk of possessing personally identifying information. There are consumer protection laws all over the world that if you don't hold that information securely, you're gonna have to pay huge fines as a retailer. So these kinds of systems, I think, are going to go crazy once people realize that it's going to reduce, the fraud and the errors, the risk. It's going to streamline the whole process. There are some messy corners of things that we need to solve, but by and large, this system exists. How many credentials have you guys already issued on the system?
To add to that, there's a lot of future use cases we can get to, but currently the system's been live since 2017. We have 70 stewards around the world that are running the network for the transactions to be accepted for the issuers. And we have tens of millions of credentials that are in production now. In particular, the government of British Columbia and the government of Ontario have both launched their verifiable organizations networks. So you can actually go look up verifiable credentials for any registered business entity in either of those Canadian provinces. So that's a place where you can go look at kind of a lot of public information. And those sorts of registries also help bootstrap a web of trust so that you can find introductions to organizations that you know about that will then extend to allow you to find keys that you can trust for lots of other issues and topics.
I have a question. Recently I set up an online account with TD Bank, Canadian, Toronto Dominion Bank, and they were trying to verify who I was. So they gave me a list of questions of, which address is identified with you. And it was like someplace I lived, 30 years ago, right? And I felt this is really creepy. Number one, why they know this information, number one. And why they think that verifies to me. And what if I have a senior moment and I've just forgotten that stuff and I won't, so how would your system change that interaction?
Well, it's even more dangerous because the Equifax database in the US was stolen.
Right.
And so the attacker probably has all that printed out on a lot of double-sided sheet paper, and he can answer the questions a lot faster than you can.
There are better you than you, is that what you said earlier?
But that aside, the idea is that knowing the information shouldn't be sufficient to authorize you for knowing the information, right? You need to have some mechanism of authenticating yourself and doing key recovery that's not shared with everyone else. This is the other danger of doing a centralized EID system that relies on biometrics, is that the biometrics all end up in the central database, and everyone's going to use those for authentication. And then if that database gets stolen, you can't rotate any of those secrets.
Even if they steal it, the IRS has the same system, and they implemented it a few years ago, and they found that the legitimate users only got 22% success rate identifying themselves, but Nigerian citizens had like 60% success rate.
Well, and
what's
what's
more
more
is they're better at identifying you than you.
From those mechanisms of using just correlatable attributes, they're suffering tens of billions of dollars in fraud every year on tax returns.
Yeah.
And so we really need to get to a system where we have some attributes that are protected that we use for key recovery and key management, and not for interaction and communications. And so one of my hopes is that we can get this system that has pairwise identifiers and does this context protection out into the wild before all of our biometrics are compromised.
Yeah, in Hong Kong we host many meetup in the past, and this is definitely my favorite. So first of all, thank you for this. So speaking from a Hong Kong citizen, I really like Indy. I really like what you propose. So can you share a little bit about in your past experience, for example, engaging with the Canadian government project, and for each of us in Hong Kong, if we want to make this one of the government system, if we happen to see a government official in Hong Kong, how can we all do a little bit of help, and what should we say?
So I'm not privy to how government officials will react. Let me first say that I'm in no way an expert on any of that topic. In our experience dealing with the Canadian government, they have very strong laws that protect the information sharing between different units of government in Canada. So it was actually a very strong and hard requirement that they could not interoperate across contexts without consent. And that really was one of the things that sold them on this type of a system as to why it was necessary. And has driven a lot of the adoption. Though they understood very quickly that there's a bootstrapping problem. It's very difficult to put a digital identity in everyone's pocket all at once. And so stop thinking about use cases that work really well when everyone has one, and start thinking about use cases that work well when no one has one yet. You need to think of it like a recursion problem in computer science. Start with a base case where one person joining has value, and one more person joining has more value. Because then you'll create incentives that drive adoption forward from nothing to everything. And in the case of the Canadian government, what they discovered is that they already had public registries of lots and lots of information. And if they issued credentials for everything that was in the public registry, they could do workflow automation between all the government departments. And now they have a big pile of credentials that has lots of business value, and business owners are looking at that and saying, I want those. And that gives them a motivation to go get a wallet and to go get those credentials and to start taking the key management seriously. I compare it to a lot like when you have a young kid who just barely first gets a wallet and they don't have any money in it, they lose that wallet a lot. Because there's just not any reason to hold on to it. But once you're grown up and you have all these things in your wallet, and you know how painful it is to recover, well now you have a reason to keep track of it and make sure you don't lose it anymore. So we want to look for use cases that drive that adoption forward. In particular, we found that if the credential issuer and the credential verifier are the same company or the same organization, that's a really easy place to bootstrap that kind of adoption and then work your way out.
So, something that's a little less cerebral. I'm from Las Vegas in Nevada, and recently we were able to convince the Nevada government to pass a law that allows blockchain to be considered a way of storing records that the government would recognize as official, right? So they have this thing where you have to notarize documents or whatever for the government to recognize them, and having a digital signature and having it stored in a blockchain and all those things, the government decided, okay, we'll accept that. Now, why this was important is they've recently decriminalized cannabis, and they have a lot of rules about being able to keep records on the production of cannabis. And the cannabis industry wanted to use a blockchain to do that. Okay. The way we convinced the lawmakers is quite literally, I was in a group of people that took some of the lawmakers out, and we got them drunk. Cannabis was not legal, so we couldn't get them high, but like literally my suggestion to you is to call your politicians, your lawmakers, and invite them here. That's my solution.
We will send them 2 ways.
Or that too, you know. I'll get a drum.
Well,
But like seriously, engage them as just normal people. Like, hey, we have this thing, this really great idea. We'd like to try it out. We want to hear what your concerns are. We would like to tell you what our concerns are. Invite them here and keep them here. Like, keep bringing them here and figure out what it is that will get them here and do that, right?
Well,
in Vegas, we just bought them beer and they were like, okay.
Well, and also note that it was no longer a foreign solution, right?
Right.
It was their constituents who were helping to develop it, who understand it, and who want to make it work. And that's one of the beauties of open source. Is the sovereign network is not something that comes from a faraway place. It's something that comes from all the code contributions that people have made here. You know, we've leveraged technology like Caliper. We work with the folks who are local in your communities, and you are all invited to help make changes in code commits. And it doesn't matter if you're a brand new student or if you're an expert on identity technology, there's something that you can do to make a difference. And when it's not a solution that comes from a faraway person or from a faraway place, it makes a big difference in terms of how you can adopt it.
Hong Kong is physically small. Chances are your politicians are your neighbors. Right? Like, go knock on their door and introduce yourself. Invite them here.
They live on the peak.
So to be honest, well, that's why for our hackathon, we actually had the Department of Justice as our judges. We had the SFC as mentors. We have EHKM as observers. That's what we're trying to do. We're trying to, as part of this journey, say, look, we're all trying to learn about this, and you learn with us together, and ideally we co-create.
Well, and you know, as a technologist, I usually invite all the developers to come participate, but it turns out that the network that is sovereign needs business people and legal people as well. We have a global policy working group where anyone who's involved in legal policy, especially privacy law, locally to Hong Kong, we would love your participation in it to help making sure we get it right so that when you do convince somebody and they look at it, they go, wow, this really will work.
And we have a smart contracts working group at Hyperledger too, where we have lots of technologists and not enough lawyers. So
Never hear that one. No, but I think you know, it's very timely because actually in Hong Kong we now have the EID rolling out, right? So, but what I would actually add to that, and I think for those who are interested in this space, is really to use the word smart city. Everybody wants to have a smart city, right? And it really starts with identity, and with identity, you get to interconnect with a lot of services, right? So I think that that can be, and I also like what you said too, because it reflects what I had observed, which is a lot of the decentralized identity use cases were really with refugees, economic refugees, really back to your no alternative situation, right? And so they are. So I think these are great lessons for a lot of us to learn as we try to better understand and look for better adoption of these great technologies. Any other questions, please? Oh, two at the back. I'll go around.
Hello, thank you for the talk. Just one question about trying to understand the system. What happened when I try to change, modify my identity? Because in the old world, in the centralized world, if I change my password, I can easily go, and I can understand, I can change my username and password. But if, let's say in this system, if I change my address to a different place, and then I change my, let's say my phone number, then the whole identity is cascading. I mean, I need to go to the issuer, and then the issuer go to the issuer. Then but then maybe I forgot where did I get my address, and then so the problem will at the end will not able to identify me, but I'm authentic person. At the end, if using this system, maybe I didn't understand correctly.
Shall we get the second question and then we answer together? Yeah.
Hi. Can I just pose a scenario where the chain of verification, one verifies another, where the distant verification at the end of the chain has no relation or even perception by the beginning of the chain. So how would that chain of reliance and liability cascade through?
So the first answer for the first question is, how do I change my information? Remember, none of the data is stored on the chain. It all ends up in the wallets that are at the edge. So when data changes, it changes at the edge. And you're looking for data where someone authoritative can verify or validate it. You don't trust data because someone self-signed it. You trust data because it's known to more than one issuer that others trust. And so you simply revoke the old data and you issue new data. And because the data is stored at the edge, and because it's proven in zero knowledge, people will want to seek proof over and over again for that data. And anytime the data changes, you'll present a different proof. So there's nothing about the system that creates an immutability. And also, you're never expecting that someone's going to have a single identifier. If you want to throw away the context you had previously, meaning you want to throw away your old username, you simply or get a new key and you can create a new connection.
So
and you can have multiple connections to a single party.
So I can change my legal name whenever I want?
Well, remember, what's your legal name? Who is the issuer of your legal name?
It would be what's on my birth certificate or what a court of law has agreed is my legal name.
So those are the issuing authorities. And if you want to change your legal name, you have to convince them that they have processes for that. Right? So it's not self-sovereign identity in the sense that you can say whatever you want. It's sovereign identity in the sense that you can assert any data that someone's willing to issue to you. Right? Which means that in the second case, right? If you'd repeat your question one more time.
Okay, so I verify the person in front of me, and he verifies the person in front of him. So this whole chain, and we've come so long where the end of the chain person has not been perceived by the front of the chain person. And how does the reliance and liability cascade through when there's absolutely no possibility of foreseeing what people are going to do in the future or vouch for the future?
So remember, let's see if we can get to the right slide for this. Right. There we go, there was one. This party is in charge of what they're willing to sign.
Yeah.
This part, I have to be careful, I can't touch it. This party is in charge of what they're willing to share. This party is in charge of what they're willing to trust. When there is a chain of proofs required to trust, it's all up to the verifier. The verifier gets to decide whether the contextual transformation from one issuer to another is valid. If I'm willing to accept your university card to give you a discount at my sandwich shop, I can. I am making a translation from the university's authorization system to discounts on sandwiches, and I've decided that that's valid for my business case. And that might mean that I need to decide, well, who's a valid university? Right? Maybe I'll only accept HKU cards and not somewhere else. Right? Or maybe I'll say any valid Chinese-speaking university can get a discount at my shop. Right? I can have my own rules of who I'll trust. And I might have to go to multiple transformations to do that. I might have to say, I need to know who's a valid country according to the UN, and then who's a valid driver's license issuing authorities at each of those countries, and then who's valid driver's license offices in each of those countries. I might have to walk several layers of trust in order to automate the system the way I want to. Or I can just say, I don't care. It's up to me to decide who I'm going to trust and how.
Now, what about cases where there's a mistake, not misuse, where there's genuine mistake, and then you're trying to put back into the original position, and then obviously people are trying to blame each other, and you're trying to pass off blame and the liability to other people.
That is a real problem in the real world.
Yes,
you still have to deal with that problem.
Right.
First off, that's why revocation is so important. You need to have revocation at every layer, and revocation needs to work in a privacy-preserving way. Because when someone tries to prove something in real time, you need to know whether they're revoked or not in real time. And that way, when you do detect a mistake, you can take it back. In a system that doesn't have revocation, or where revocation reveals who is the party involved, you end up with unique identifiers that must flow between all the parties, and then the contextual relationships of I'm proving to you versus I'm proving to you, those collapse because then you can start colluding with one another.
So are there any penalties for misuse or abuse, or just simply revocation?
Every governance framework has to decide what the penalties are going to be. Different governance frameworks have very different stakes. If you're just doing an online social website, it may be that the stakes are really low. and I don't have to care. Mistakes are not a problem for me because they don't cost me very much. And in many governance frameworks, it's okay to be lazy about this. It's okay if revocation is 2 or 3 days old because you've authenticated enough that I can carry the risk and I can remedy the risk if something went wrong. Right? That's totally okay. We're not talking about making a smart contract system where the state of the data is stored on chain. So reversibility is still a thing here, and context about what transaction is actually trying to occur is also still a valid
How do you challenge revocation? How do you challenge the revocation?
You can detect revocation before you present proof, and then you can go talk to the issuer's agent and you can ask for a new credential. Right? So because everybody in the system has cryptographic keys and can receive cryptographic messages, you can actually automate in real time the renegotiation for new credentials, just like you have to deal with revocation. So it means that all of those processes for recovering your identity can also happen cryptographically in real time, just like proving can happen cryptographically.
So this is where this gets really interesting, because when you start mapping this onto human and governmental processes, you quickly realize that there's a lot about our society that relies on, or at least we're okay with, a certain amount of error, right? Well, let's say, in the interest of a free and fair election, we're gonna be okay with some people who probably shouldn't vote are voting, right? As long as it's a small percentage, we don't really care, right? It's like, fine. We would rather have everybody be able to vote rather than to have to check everybody to make sure that you're a legal voter, right? Because doing those checks disenfranchises some voters who, for financial reasons or whatever reasons, can't get whatever government-issued ID is required to vote, okay? This also applies to things like refugees and immigration, and like, you could be a student in a country, have a student visa, go to school, get a job. You're still under a student visa, you're legal, but then your student visa expires, and you want to finish out your internship for a couple weeks before you fly home. Generally, most countries they say they aren't, but they're like, it's fine. As long as you eventually go home, it's like, whatever, we don't care. With something like this, where you have immediate revocation and immediate verification of revocation, we're going to drive down that slop to nothing. And this is going to be a real problem for every country on this planet, okay? Here's the one example I give that gets a lot, that really brings this to a point, is that a lot of people lie about their academic credentials.
No, really?
This is known, okay? This has been studied, there's real statistics. There's lots of people who will say, oh yeah, I have a degree from Harvard, and because it's really hard to verify that, most companies go, all right, seems plausible, you seem like a smart person, we'll hire you, okay? What happens now when you apply for a job, you have to put a QR code on your application, and they can instantly verify that you do or do not have a degree from a university, okay? That seems like one problem, and that seems okay, right? People won't apply for jobs where you have to have a university degree. You can't lie about it anymore. Okay, now what happens when we put this system in place and Google runs the resumes of all of their existing employees through the system, and they find that 20% of Google's employees lied to get their job. Now, they may be employees that have worked for Google for many years, 10 years, 20 years. They're good employees. They didn't qualify originally, but they've been a good employee, they've been working hard, they're valuable to the company. Does the company fire them? Or does the company pay them to go and get the training they originally claimed? Do they give them a stipend to go back to school at night and get the degree they lied about originally? Okay, so this is one scenario. So now what happens when Google finds out, or Facebook, or any of these big companies find out all these people lied? What happens when Harvard learns that there are 50,000 people out there claiming to have Harvard degrees that don't? And now Harvard knows who they are. Does Harvard now go to all of their employers and say, these people are lying? Because they definitely want to protect their brand as an elite, exclusive university. Or does Harvard build a program that says, okay, all of you that have been lying for years about having a Harvard degree, if you pay us a little bit of money, we'll get you into a program, an extended education program, and we'll try to bring you up to Harvard standards of having a diploma from our university. Okay, these problems are going to come, and we're going to have to think as a society of how we want to punish people who have been taking advantage of the slop in our system. I would argue that we should probably hug rather than hit. Okay, this is one of those systems where we're getting to a point where computers are going to be able to prove everybody a liar, and we should probably have a way of saying, okay, we get it, you lied, let's try to make it right, let's move everybody forward. This is going to be a big deal. In the United States, we have this thing called E-Verify for voting. Okay, it doesn't exist. It hasn't been actually implemented because people are afraid that E-Verify for voting or for employment will immediately point out the millions of immigrants that are in our country illegally. Okay, and the reason people fight vociferously, very energetically, to defend these people is because they're not convinced that when they are outed as an illegal immigrant, that they will be treated humanely. And if we can assure people that there is going to be humane treatment, I think suddenly everybody's going to be okay.
These issues that are described are really important problems with centralized identity systems. When you're relying on just a single issuer or a single source of information, there's not a way of triangulating to find errors. When we have a multi-sourced identity system, we don't have to rely on only the first tier of authentication, because that tier of authentication is doing some validation process behind the scenes. They're doing something to verify your birth certificate or to verify some other set of data before they issue that credential in the first place. And when we have a multi-sourced identity system, we can say, well, we have the primary credential which we trust, but you know what? We know where the primary credential comes from. So we can trust the aggregate of the secondary sources. In fact, we might even be able to trust the aggregate of the tertiary sources. And we can automate that because we know who those people are. And because we can do that, we can account for the mistakes that disenfranchise people and the mistakes that would make it so that the visas don't work, or that makes it so they know whether or not you're a good employee. Right now, a lot of the certifications that are the most difficult to obtain or that have the most tyranny involved in them are simply because we don't have any other source of trust. And so we use some proxy for that trust. And when we have a multi-sourced identity system where we can verify a broader source of information, we have another way of deciding whether someone's trustworthy or whether someone's operable for a particular capability. Right? For instance, in the Google employee credentials sense, they might have lost one of their primary sources of trust in the university degree, but if they can prove a broad base of capabilities that are equivalent, we can continue to employ them. And this gives us tools to use carrots instead of sticks. And so minimizing disclosure, remember, is about making so that we have context for identity. And once we have context for identity, we can actually increase the amount of information we can share. So instead of just saying, I have the right to vote, you can say, I have the right to vote. Oh, that didn't work. Well, I can prove I should have the right to vote, and now we can do something about it. Right? And that helps us reduce this, both reduce the fraud and increase the interoperability.
What you described is children's play, because although it's not relevant to this subject, genetic verification will set off a landmine, because we know that 20% of people are not genetically related to their legal fathers. And always the first child is almost, the second one is a 40% chance. This is going to set off a legal landmine all across the world.
I can agree with you. My ex-wife is a forensic scientist, and when she was in the university, she was doing genetic disease studies, and where she had to do familial relationships of genetics. And I just distinctly remember her coming home one night going, I'm never gonna have another man's baby. She was like, I'm shocked at how common this is, right? And this is another one of those cases where I think maybe there should be some legal frameworks that we should be talking about now about not only do I own my genetic data, but I may also have some say in the revealing my genetic relationship with people around me as well. Because imagine the destructive.
And remove guns, remove guns.
Next. Well, I didn't know whether you want to take one. I was going to end it, but since we had that question, I don't know whether we should have one last question.
I don't know if we can go that close to the edge.
Exactly. One last one at the back. Larry.
Margaret, keep up. What about all the people that are imprisoned who are innocent? Could it help that as well?
Well, it's important that we have this construct of revocation. A system that's forever is not a system that works. You can take things back for a lot of reasons. And so you don't know what a revocation means. You only know that they took it back. Revocation means that someone issued something in error. It could mean that you failed to continue to qualify. It could mean that it never should have been in the first place. And it's important when you're operating in a context that you understand what's at stake. I think there's not a place where more is at stake than in our judicial system with respect to what you just mentioned. Credentials don't solve that problem, but hopefully credentials help us make some of those problems more apparent.
I mean, to add to that, we can use these systems to improve the evidence management system, okay? But wrongful imprisonment is a function of humans being, the jury, and humans being the law enforcement collect evidence. Again, my ex is a forensic scientist, and she's actually I know it sounds funny, she's my ex, I adore her still, we're still really good friends. She's a genius. I mean, she's an award-winning forensic scientist who has cracked many cold cases. She's been on TV many times for, cold case files, that kind of stuff. She solved a murder case that was 40 years old and exonerated a man who had been in prison for almost 20 years. Those kinds of systems are, like those false imprisonments really they fall under the fact that our technology wasn't good. Like the reason she was able to exonerate them is because the technology has gotten to the point where she can actually get a DNA profile off of some evidence that was collected 40 years ago. It was so faint that technology back then couldn't do it. Like Nathan said, I don't think credentials can solve this problem, but we can hope that our sensitivity, our technology sensitivity, can get to the point where we can start collecting. We can look at old evidence, right, in a new light, and be able to go then and correct some of the mistakes in the system. It's different depending on where you are in the legal system, but I know that in the United States they almost never throw away evidence. I mean, the reason she was able to exonerate this person was because they still had the cigarette butts from the crime scene that were collected 40 years ago. Okay, it's a thing in the United States. They have huge frozen vaults where they keep evidence for basically forever. Especially if it's a murder case, right? Anything that they have to keep it for the statute of limitations. So I can't speak for other countries, but a system like this could aid in helping to exonerate people, and potentially finding the actual criminal too. So again, like when you're interfacing with the real world, it gets messy. This is never going to replace the fact that we're going to have humans as law enforcement, humans as juries, humans as judges, that kind of thing.
Well, I'm so glad that you talked about immutability and also revocation, because as lawyers, that's one of the parts that we kind of are troubled with, right? So with the smart contracts that was talked about earlier on, we know we've drafted the contracts. We know things can go wrong, right? And you can't address every single permutation combination. So, but I think we've been so lucky to have you, Nathan, to share, your very lucid explanations of what is a very complicated area, and thank you very much as well, David, and the rest of the panel. So can you all please put your hands together again? So some of us have had dinner and others have not. So I wanted to end here by thanking all of you for being here on a Friday evening. So these are the hardcore folk that really wanted to be here, but I think you all agree that you were well rewarded. This was really remarkable. We're so lucky to have you here, and we look forward to being in touch and maybe contributing as well. If you want more lawyers, I got lawyers for you. All right, but thanks so very much, and if you have any questions, please come step forward and speak to the panelists. Thank you again.